So let's consider this problem from the study guide, problem 1. And we have a reaction that is given to us, and we're asked to find how many grams of sodium chloride, which is here a product, can be produced from how many grams from 28.4 grams of sodium hydroxide in the reactants. So they don't mention anything about the other reactant, chloride, so I guess I'm going to assume that it's an excess, or that it just doesn't have anything to do with limiting the reaction products, and that this is the limiting reagent. So we can use this balanced, hopefully it's balanced, chemical formula, and then we will convert these grams to moles, use the mole ratio inside of a balanced chemical reaction, and convert moles of NaOH to moles of sodium chloride. And since they're asking for grams and all the answer choices are in grams, we are going to convert the moles of sodium chloride that we get to grams of sodium chloride. So it'll look like grams of NaOH to moles of NaOH to moles of sodium chloride to grams of sodium chloride. So let's just make sure that this is a balanced chemical reaction before we start working with it. So I see 6 sodiums in the reactants, and there's like 5 sodiums over here and 1 sodium over here in the products. There's 6 total. 6 chlorides, there's 1 chloride here, and again 5 chlorides, so 6 and 6, so that's balanced. OH, there's 6 O's and 6 H's, and there's 6 H's and 3 O's here and 3 O's here, so that's 6 O's. So the H's and O's are balanced. So everything's balanced. We can use this chemical reaction to figure out how many moles of sodium chloride there are for every mole of sodium hydroxide that we start with. So we need to figure out what the molecular mass is of sodium chloride and sodium hydroxide, so that we can convert from grams to moles and back to grams again later on. So to do that, I'm going to use the atomic masses to find the formula masses. The atomic mass of sodium is 22.98, etc. Oxygen, it's about 16. Hydrogen's about 1.08. Sorry, 1.008. And also need chlorides, 35.45. So I've inputted the masses for each of the elements, and now I'm just going to make the formula mass for sodium hydroxide. So sodium hydroxide has one sodium. I'm going to multiply that by the atomic mass. It has 1 oxygen. I'm going to multiply that by the atomic mass of oxygen, and it has 1 hydrogen. I'm going to multiply that by the atomic mass of hydrogen. So I get that for the formula mass sodium hydroxide. For sodium chloride, there's only 1 sodium and there's only 1 chloride. So if I multiply the atomic mass of sodium times 1 and add 1 plus the atomic mass of chloride, 1 times that, shouldn't be plus, should be times. I get this for the formula mass. Okay, so this is the formula mass for NaOH, and this is the formula mass for NaCl. And let's see, we were given that we start with 28.4 grams of NaOH. So if we look at our units really fast, we know how to convert things using our units. For mass, we have grams. For formula mass, we have grams per mole. Like all those things we calculated were in grams per mole. And then for moles, we just have moles, right? Like if we want to count moles of something, we just do moles. moles. So we're given a mass, and we want to get to moles. So if we start off with grams, our unit conversion would be, we want to multiply by grams on the bottom and moles on top to convert this thing to moles. Let me get rid of that. So what that means is we're going to be taking the mass and then dividing by the formula mass. So if I look at that problem again, and I say, okay, we start with 28.4 grams of NaOH, we're going to use the calculated 39, or it's about 40. So like 40, the formula mass is 40 grams per mole. So we're going to actually divide by that because we want to have grams on the bottom and moles on top. And what we'll get is, use Excel to calculate it, mass 28.4 moles. Okay, so our moles of NaOH, we have 0.71004. So let me see if I can find it. We have .77 moles of NaOH. That's what we've calculated so far. And if we go back to our formula, or not our formula, but our balanced chemical equation, you can see that for every 6 moles of NaOH, we produce 5 moles of NaCl. So what we can do is multiply the moles of NaOH that we just calculated by 5 NaCl over 6 NaOH. So if we take that moles NaOH and multiply it by 5 moles NaCl over 6 moles NaOH, we'll actually cancel moles NaOH and we'll be left with moles NaCl. So I'm going to multiply moles NaOH by 5 and divide by 6. That's just what I did, but in Excel. And I get that there's 0.5917 and some change moles of NaCl. And then I can multiply moles by formula mass to get grams, to get the mass in grams. So this is the answer, 34.5806. Since we started with 3 sig figs, and we've been using a bunch of formula masses that I have many significant digits, like at least 4. I'm limited to 3 sig figs, so this would be like 34.6 if you were reporting it as a number. So let's see if that's consistent with any of the answers. So my guess is the answer would be E, and let's see if that's right. Let's hope it is. Yay! So E is right according to the answer key. Sure. This one? Okay. So this is how I went from moles NaOH to moles NaCl. And let's see if I can undo enough to get back to where I had a lot more work. So that's how I converted from mass to moles of NaOH. We can actually look back at some of the results and make sure that, like, along the way, whether or not things are making sense to us. So let's check out some of our intermediate results and just kind of like look at the answer choices and say, wow, this makes sense, this doesn't make sense. So if I had to eyeball this stuff, right, and look at the answer choices. So we have lots of different answer choices. The moles of NaCl that result are almost as many as the moles of NaOH that we put in, and the mass of NaCl is greater than the mass of NaOH. So just by eyeballing this, I would have to say that we probably would have at least as much mass coming out in NaCl that we put in as NaOH. So I would say that without doing the calculation that D looks wrong, C looks wrong, and now I'm just left with B, A, or E, and then I'd have to do the math to figure that out. When you're doing this in an exam, I would recommend actually that if you don't get one of these answers pretty close, like within maybe like 0.1, then you should check your work. Like if you get an answer and it's like within like 0.1, if you get like 49.8 or something, or 49.7 or 49.9, then that's good. I would leave it alone and find a way to double check it later on, but it's not a priority. Move to the next problem. If you got something that's wildly off, like it's off by more than a change in one of the digits by 1, I would maybe write down the closest one, and I would mark it to go over it again later on. So, like, you're not done until you really like double check everything, but I would say that like if you're off by more than like one of the digits by just a matter of 1, I would say that it's actually like pretty dangerous and you should think about redoing it.